Hey folks, continuing our crash course, let's talk about the rules of matrix multiplication before we jump into the how the matrix multiplication in terms of the actual calculation is done, which is very important. That's why I just want to keep that byte episode very separate. So what are the rules of matrix multiplication? In the last episode, we did see what is the matrix notation, and we'll just go back on this one and try to use that. But let's understand. So what are we talking about? How do we multiply? So for example, we have got two matrices like this, A and B. Let's say this is A, or let's say this X, like we had here, right? We had A and we had X over here, or you can take this one, A and X. So when you multiply A and X, the first thing that we need to find is whether this multiplication is possible, because that's where when you multiply the two matrices, it's not a scalar number. In the previous episode that we saw that it's possible. We are multiplying two matrices, and there are a lot of rules when this multiplication is possible to start with. And in exam, I don't think you'll really get a trick question, but if you get, I just wanted you to have a background on this one. So when we multiply A and X two matrices, is it even possible? And how do you check that? So the way to check is, whatever matrix is on the left, when you're multiplying two matrices, again, it has to be two or more matrices and not the numbers, okay? So whatever matrix you have on the left, you write the order of the matrix, okay? And say in this case, let's say the matrix is 3 by 2. Whatever is on the right side, you write that order. Let's say it's 2 by 3, okay? And the way or the rule that is important for this matrix multiplication to be possible and to exist is these two close numbers who are like closer to each other in terms of distance, 2 and 2 should be same. And what does it mean? The row, or sorry, the column, I always kind of mess it up here. Okay. So the number of columns on A should be equal to number of rows on B, which is on the right side. That's a simple rule. So if they are not matching, then you don't have to solve the problem, because you cannot solve. You can simply say, since this rule, number of columns of A on the left side does not match the number of rows on B on the right side, matrix multiplication is not possible. Okay, that's how you write. And after you multiply over here in this example, let's say the multiplication is possible. This is matching. Okay, this is matching. After you multiply, how would I know what will be the order of the output matrix, which is a matrix B here? So once we multiply, whatever is going to come on the other side of the equal sign, like say if you have AX is equal to B, what is the order, how many rows and columns this matrix is going to have? And the rule for that is, by default, when you learn the multiplication, you will get it unconsciously, but the rule for that is whatever is the remaining two number, not the inner two, the outer two which are separated by the distance 3 and 3, whatever that number is. The order of the output matrix, let's say AX is equal to B, so the order of this matrix in terms of rows, order is nothing but rows by column. That order is going to be determined by these two numbers, where whatever is the first one, the row, number of rows on matrix A, number of rows on matrix A, that is matrix A on matrix A, and whatever columns are matrix B, the final order will be that. That means in this case, it's going to be a square matrix because we have 3 on both the sides. So the order of the output matrix or the constant matrix is going to 3 rows and 3 columns. That's what it is. Similarly, if you see here also, right, since it's a linear equation, we know that the multiplication is possible, but you can also check that fact here. Okay, let me just make some space here by erasing some of the numbers here. But let's say, okay, I'm going to use this real estate. So what is let's say we have AX is equal to B in this case. Okay. So what is the order of this? This order is 2 rows and 2 columns. So I get 2 rows and 2 columns. What is the order of this? It has got 2 rows, X and Y, along the X axis, and 1 column. So this is X is 2 rows and 1 column. And to determine if the multiplication exists, like we saw here, take the inner 2 numbers, okay, which is these 2 numbers should match, where we're talking about the columns of the left side matrix, and the rows on the next matrix should match. That means multiplication is possible. And what will be the order, how many rows B itself will have, will depend upon what are the remaining 2 numbers on the other side, which is the number of rows on A, 2 rows. So this is going to be order of 2 by, and the number of columns on the other side. So we match the remaining 2. So we take the rows of this and we match with the columns. So it's going to be 2 by 1. So this matrix is going to have 2 rows Okay, so that means there'll be 2 rows and 1 column. So you'll have like this, just there's 1 column and there is one element here and there's 1 element here, which is what you will see in this example over here also. So it's 8 and 6, which is over here. If you see the constant matrix, there are 2 rows along the x-axis and 1 column on the y-axis. And likewise in the 3 by 3 matrix also, you will see if I plot Ax is equal to B, the same thing. This one, A has got 3 rows and 3 columns. I know that. X has got just 1 column but 3 rows. I write the rows first, 3 into 1. So is the multiplication possible? Yes, because these inner 2 numbers, the columns on the left and the rows on the right match. And what will be the order of the constant output matrix B? That will be determined by the remaining 2 numbers, which is 3 by 1. So we'll have a matrix which will have 3 rows by 1 column, which is what we have here. We just have 1 column, but we have got 3 rows. Okay. Another important thing is, like I told you, in matrix multiplication, when you multiply 2 matrices, don't confuse with the scalar multiplication. Okay. When we multiply 2 matrices, the order matters, because if you multiply A and B, which has different orders, it's not same as B is equal to A, because the order are going to be different. Number of rows and column are different. For example, if you flip this around, where you take the x1 first, okay, so x1 will have, let's say x1 will have what is x? You have got 2 rows and 1 column. Let's say I'm going to flip this here. Okay, for demonstration purpose. Sorry about the mess, but it's all doodles, so I can erase. That's a good thing. Okay, so let's say instead of Ax is equal to B, I'm going to say, if I'm going to switch the order and x into A, let's see if the multiplication is even possible. What is x? The variable, it has got 1 column and 2 rows. I'm going to write the rows first. So the rows multiplied by column, this is x. And what is A? A is a square matrix with 2 rows and 2 columns. So I'm going to write 2 by 2. And if you take the inner 2 numbers, they do not match, and hence multiplication not possible. So when you multiply 2 matrices, not the scalar, not to get confused with the scalar, which is just a number. When you multiply 2 or more matrices, the order of the matrix matters, meaning which matrix is on the left side and which one is on the right side. So that's just a quick reminder on that one. And that's why I put here, do not forget this rule here. Similarly, over here, this is an example where the multiplication is not possible. Okay, there are we are going to multiply 2 matrices, A and B. The matrix A on the left and this on the right. The left one has got 2 and 3. So the left one has got 2 and 3. Sorry, I need to write the rows first. See, I do it all the time. So this, you guys should avoid this mistake. Rows first and columns. On the matrix B, again, I need to write the rows first. Again, this is 3 by 3. And these 2 numbers which are closer here, columns on this and rows on this, do not match. So multiplication is undefined or is not possible. Their product cannot be found, right? So that's what it means. Just a quick rule here before you get into the actual algebra, which is a process by itself. Just a quick rule on whether it happens or not. I'll see you in the next byte, guys.